Good evening. Welcome to Cornerstone Home Inspector Education Center. Tonight we have Mastering Kitchens and Bathroom Inspections. Our webinar on inspecting kitchens and bathrooms. These are two of the most critical areas in any home inspection. Um, Tonight, this presentation will equip you with the knowledge and skills to conduct a thorough professional inspection in these highly used spaces. We're going to go over common issues and ensuring safety for clients and tell you reasonable, actionable reports on what to write, what not to write. If you have any questions during the webinar, please feel free to put them in the chat bot or break in. If you do break in after you're done with your question, please mute your microphone, um, and we'll get started. Tonight's agenda, we're going to do the purpose of kitchens and bathroom inspections, a detailed of the examination of the plumbing, electrical cabinets, ventilation, any kind of safety hazards in kitchen. We're going to go through bathroom inspection. We're going to look again at the plumbing, the ventilation, moisture control, electrical systems, safety features in bathrooms. We're going to go through common defects and reporting, uh, identifying frequent issues and how to write clear and concise reports. And at the end, we'll have any kind of wrap up that we want to do. Any questions? The importance of kitchen and bathroom inspections. Again, to repeat, these are high use areas. These are among the most frequently used spaces in any home, and they experience significant wear and tear over time. Safety concerns such as electrical issues, water damage, and slip and fall risks are common in these areas. Um, they can be complex systems in these rooms, contain intricate plumbing, electrical, ventilation systems that require careful examination. And there are big value impact on the effect of the property's overall value and marketability. As you go through a house and you do many inspections over the years, you'll hear this. Well, how do I get value out of my house? Kitchens and bathrooms. Nobody cares about a remodeled bedroom. So you're not really caring about that. Okay, so as if you're a member of Cornerstone for a while now, you know that we have to go through our state standards. And we have next two slides are in our state standards, which cover Connecticut, New Jersey, Massachusetts, New York, and Rhode Island. What I did for this presentation is on certain of the state standards that were common in all the states, I put these down in certain slides. So let's just go through them quickly, and then we'll move on with the webinar. Water supply and distribution. You In all these states, you have to inspect the interior water and distribution systems, including all fixtures, faucets. You have to describe the water supply piping material, if it's PEX, if it's copper, plastic. Um, Drain, waste, and vent systems. You need to inspect all the drain, waste, and vent systems, including fixtures. Document the piping material used in these systems. Water heating and fuel systems. You need to examine the water heating equipment, fuel storage, and distribution systems. Describe the equipment and energy sources. An example would be your water heater, whether it's electric, gas, oil fired. That all has to be in your report. Um, Drainage systems. You want to inspect drainage pumps, sump pumps, and related piping. For properties with well, describe the visible components. Shutoff valves. Identify and document the location of the main water and main fuel shutoff valve for emergency access. Exclusions. In all these states, you're not required to test valves except flush valves and faucets. Determine system adequacy. Inspect exterior hose bibs, fire suppression systems, water quality, wells, or laundry equipment. So on the state standards, this is the minimum that you have to do and what you don't have to do. Obviously, if you want to run kitchen appliances, if you're going to offer well water quality check, you can do that and always go, if you can't go above the state standard, but these are your state standards. Um, what we also put in tonight's webinar is state standards for appliances, and we have a breakdown the state standards concerning these appliances. So, and we're just going to go through them real quick. In Massachusetts, you have the inspector must report on countertops and a representative number of cabinets, permanently installed cooking appliances, dishwashers, and garbage disposals. The inspector shall also note signs of water penetration, operate a representative number of kitchen cabinets and drawers, doors, and windows. Exclusions in Massachusetts are not required to observe and report on the following: paint, wallpaper, other finish treatments on exterior walls, ceilings, and floors, draperies, blinds, or other window treatments, non permanently installed household appliances. So if you have that microwave that's just sitting on the cabinet, leave it alone. Rhode Island shall do countertops, represent a number of cabinets, the existence or absence of bathroom ventilation other than a window. General exclusions: inspectors are not required to inspect household appliances. So you go into a kitchen, you're good. You don't have to do the fridge or cooktops or anything like that. But again, you want to go over the standard. New Jersey, household appliance inspections are limited to the kitchen, range, and oven to determine the operation of the burners or heating elements, excluding microwave ovens, self-cleaning cycles, and appliance timers and thermostats. The dishwasher to determine the water supply and drainage, the garbage disposal. In Connecticut, inspectors are not required to inspect paint, wallpaper, other finished treatments, carpeting, window treatments, central vac systems, household appliances, or recreational facilities. Um, in New York, observe a report on household appliances. So just doesn't say, it says observe and report. That's kind of not a great standard to
Yeah,
me.
let me jump in for a minute, Jim.
Sure.
A lot of things in the standards of practice for a lot of the states that are regulated don't go in too much detail about. Observe and report is a very broad brush. Being in Connecticut, I probably do what the New Jersey home inspectors are required to do. I will at least make sure all those appliances have power, that the elements in the range, the electric range or the gas stove work.
Right.
And I'll run the dishwasher through a cycle. But let me tell you, I do not leave the kitchen when that dishwasher's going, because it could
Right.
leak around the door and create a big problem. The one time I did, and it was a small condo. It leaked all over the place, and luckily it was sheet flooring, so it didn't leak into the unit underneath. But I
Nice.
was pretty worried that there was going to be water damage in the unit underneath. But we cleaned it up in time. So, you got to be smart when you're doing these things.
100%. Kitchen inspections, plumbing systems. What we want to do is the kitchen and faucet inspection. Start by examining the sink and the faucet for any visible leaks or damage. Turn on the faucet to check the water pressure and ensure hot and cold water are functioning properly. Look for any discoloration or unusual odors that might indicate water quality issues. Under sink plumbing, inspect the pipes, connections under the sink for leaks, corrosion, or proper installation. Check the P trap for proper alignment and any signs of water damage on the cabinet floor. Ensure shut-off valves are accessible and functioning. Drainage. Test the sink's drainage by filling it and observe how quickly water drains. Listen for any gurgling sounds that might indicate venting issues. Check for any signs of previous clogs or backups. So, you know, this is all, for a seasoned inspector, this is all sort of common sense and easy. But for the newer inspectors, it seems silly, but you have to go through all these little different things. You have to let the water run. And like Stan said, do not leave the kitchen with the water running unless you have an agent or a client, somebody sitting there watching it, because that sink can overflow and have an issue. Or again, with the dishwasher, you want to make sure that you're there, if it has any problems, that you can immediately shut it off and find it. um, Checking the under sink plumbing, you want to make sure, we're going to get into more of this, but in general, you want to make sure that the trap is proper, that you have access. Is the trap removable? Is there a clean out? That kind of stuff all needs to be in the report. And drainage, I can tell you from experience, I just had an inspection out in not Woodbridge, yeah, out in the Southbury, Woodbury area, and the sink in the kitchen was gurgling. And the client was like, I don't know why that's happening. And on the exterior of the house, he had a roof leak by the vent pipe, and he put a plastic bag over the vent pipe and just secured it to the shingles. So he was not getting, the dry venting was not working. And you could clearly hear the gurgling and the lack of drainage happening in the house. So you have to check for all these things.
Jim, also when I check the drainage, I try to stop it, whether the stopper is functional or not, or the sink little basket there. I want to fill that drain up because sometimes they will not leak when you're free flowing, but when you fill the sink up a little bit and then pull the drain and that whole drain fills up, you might get a little leak. So I kind of do it that way as well. Just a little tip.
Exactly. We're just going to go through some types of faucet aerators. You have a standard faucet aerator. Basic aerators mix air with water for a smooth, splash-free flow. Threaded versions screw into faucet spout in a male or female thread types. We have pressure compensating aerators. Maintain a steady flow of water regardless of the pressure changes, helping conserve water while ensuring consistent performance. We have laminar flow aerators, produce a clear, non-bubbling water stream without mixing air, often used in hospitals and hygiene environments. Spray areas create a wide shower-like spray commonly found in public restrooms or for hand washing. Swivel and adjustable aerators can be rotated to adjust the direction or switch between stream and spray nozzles for versatile use. And high efficiency aerators designed for water conservation, reduce flow rates to 0.5 to 1.5 gallons per minute without sacrificing performance. So you go into a house a lot of times, the air, I don't know, especially on an older construction, the aerators are missing or they're clogged up. So just check your aerators. Proper pitch guidelines for sink drains. Uh, Drainage pitch slope. The horizontal drain pipe, usually 1.5 to 2 inch in diameter, should have a slope of 1/4 inch per foot of run. For pipes larger than 3 inches, the minimum slope can be reduced to 1/8 inch per foot in some cases. Um, Sink basin slope. The sink basin itself should have a slight slope towards the drain, preventing water pooling. But the exact pitch depends on the design of the sink. P-trap considerations. The P-trap should be positioned so that the outlet pipe maintains the proper slope towards the main drain, avoiding excessive drop from the sink to the P-trap. As this can cause siphoning issues. We're going to get into more um, P-traps and all that later in the webinar. Right now, types of traps. We have a P-trap. This is the most common preferred type, featuring a curved pipe that forms a P shape. Creates a water seal to prevent sewer gases from entering while allowing wastewater to flow freely. Installation typically includes a horizontal arm connected to the wall drain and a curved trap section that can be easily removed for cleaning. Most P traps are made of PVC or chrome plated brass and should maintain a water seal depth of 2 to 4 inches. Regular maintenance includes periodic cleaning to remove hair, soap, scum, and other debris that can accumulate. If you have a wife or daughter, you know about the P trap. S traps, an older design shaped like an S that commonly found in homes built before 1950. While still found in some older homes, it's no longer up to code in most areas due to potential siphoning issues that can break the water seal. The double bend design can create a vacuum effect during drainage, pulling the water seal out and allowing sewer gases to enter. If you encounter an S trap during an inspection, recommend replacement with a proper P trap and proper venting. Some jurisdictions may grandfather these installations, but any new work typically requires upgrading to current standards. We're going to get into that in 1 second. You don't see a lot of this next one. I think Stan will agree. The drum trap. It's a cylindrical container that holds water to create a seal. Um, it's effective at catching debris. They're harder to clean and less common in modern plumbing. Drum traps consist of a large chamber with inlet and outlet connections, offering feature clean out at the top, a cap at the top. While their larger capacity makes them excellent in catching jewelry and other valuable items that might go down the drain, this same feature makes them prone to clogging and difficult to maintain. They're particularly problematic in kitchens where grease and food particles can accumulate rapidly. When inspecting drum taps, check for proper sealing of the cleanout cap and signs of leakage around the connections. You're not going to see these a lot. They're usually located in the basement. Um, and that's sort of like a whole house trap. Bell trap. I don't even know anything about these, honestly. We don't see them a lot, but we're putting it in the webinar. It's a simple design to use a bell-shaped curve cover over a drain, commonly found in older floor drains and occasionally in laundry sinks. While the design is straightforward, these traps are prone to several issues, including easily displacement of the bell cover, vulnerability to pressure fluctuations, and frequent loss of water seal through evaporation. In floor drain applications, they require regular maintenance to ensure the seal remains intact. The bell cover must be properly sealed to maintain effectiveness, and the trap should be regularly filled with water in low use areas to prevent sewer gas infiltration. Modern alternatives, like the P traps, are generally recommended for replacement. I want to talk about just code for 1 second. We don't inspect to code. Okay, so how do you present this? I'll tell you what I do when we see an S trap. Hey, you have an S trap underneath your sink. Yes. What can happen with an S trap is called siphoning. The water can come out of the trap, allowing sewer gases to enter. If this happens, run the water for 15 seconds. That will fill the trap back up with water and solve that problem. You may consider consultation with a plumber to upgrade your trap underneath your sink. I don't, Stan, what do you say about these S traps?
Same thing. But I also know that sometimes changing to a P trap, let's say the house is being flipped. All right. So you would expect, if they're remodeling the kitchen or at least changing the cabinets and the counters and stuff like that, that you would get rid of the S trap and put the P trap in. But I still see S traps even in flips. Unless
Yep.
you're digging into the walls and changing because think about it, the S trap goes through the floor of the cabinet into the basement,
Right.
right? You have to reconfigure that whole thing and dig into the wall to be able to put a P trap. So if
Uh, yeah. You could put a Studer vent though,
you
right?
could,
Yeah.
yeah, but I just sometimes it's not going to happen. And
Right.
your statement about consulting a plumber would be the proper way to go,
Yes.
right? So I mean, if they can do it, they'll do it. If not, you put the water in the S trap and you live happily ever after.
Exactly. Kitchen inspections, electrical system, GFI protection. Verify GFI protection on all receptacles within 6 feet of sinks, dishwashers, countertops. Test each GFI with an approved tester. Should trip between 4 and 6 milliseconds at a 5 MA current. Ensure reset button fully restores power. Look for common issues like reverse polarity or open grounds. This might be a little bit outdated. Because it's my understanding on new construction that all outlets in a kitchen should be GFI protected.
Every single
Um,
one, refrigerator,
yeah,
everything.
yep, everything. Now, I'm not a big fan of the refrigerator GFCI outlet because I never want my refrigerator going out, but that's code, I guess.
Well,
Um,
they have audio GFIs now,
okay, so
so
you
they
can
make
put
a
that in.
sound, and
Right,
you will know that they need to be reset that way.
gotcha.
So just
Appliance connection, inspect dedicated circuits for electric ranges, dishwashers, microwaves. Check junction boxes for proper wire connection and strain relief. Verify anti-tip brackets on ranges and look for signs of overheating at connections. Ensure proper guidance, appliance grounding for the cord condition. We're going to get into appliances in a couple of minutes on the anti-tip and stuff. Lighting, test all fixtures for proper grounding and secure mounting. Verify rated bulb wattage matches fixture specifications. I don't know anybody that does that. Check dimmer compatibility with LED fixtures. How many times you go into a house and the dimmer's not working? I just tell people it's the light bulb. Um, so let's see. Look for discolorations around fluorescent fixtures. Ensure all switch boxes are properly secured and grounded. So we want to test all the outlets. We want to test all the lighting. If you are watching this as a recorded event, you need to send this code in UDS 39854. That's UDS 39854 to receive your certificate. Certificate. Kitchen inspection, continuing with the electrical system. Outlet placement. Ensure outlets are placed at appropriate intervals along the countertops and that there are sufficient outlets to meet modern kitchen needs. Check for any outlets that may be too close to sinks or cooktops. An outlet also needs to be placed on an island. Wiring condition. Look for any exposed wiring, loose connections, or signs of overheating, such as discolored outlets or switch plates. Pay special attention to areas around appliances and under cabinet lighting. Circuit load. Verify that the kitchen's electrical system is not overloaded. Check the electrical panel to ensure proper labeling and that kitchen circuits are appropriately sized for their loads. Um, Safety concerns. Identify any electrical hazards such as damaged cords, improper extension cords, or signs of DIY electrical work that may have not been up to code. So the outlet placement in your older kitchens, you're going to just have one either left or right in the sink. You know, there's not a lot of outlets. I'll get this asked all the time. What is that outlet that looks weird? What is that on the wall up by the ceiling? I'm like, that's where they used to plug clocks into. You know, those old outlets were for that. So this is pretty basic stuff. Circuit load, you'll go down into the where the electrical panel is, and you'll see if it's properly labeled and that they're sized properly. Common kitchen defects, electrical concerns, outdated wiring. Older homes may have aluminum wiring or insufficient electrical capacity for modern appliances. Look for signs of overheating or scorching around outlets and switches, which we talked about. The lack of GFI protection near water sources. Uh, this is a big safety risk. Improper appliance connection. Check for loose or improperly wired connections on major appliances. Ensure dedicated circuits are used when required by code. Overloaded circuits, multiple high wattage appliances on a single circuit can lead to trip breakers and fire. Recommend upgrades if necessary. The other thing too, I forgot to tell you is when you're running these kitchen appliances, you got to make sure they're shut off. Okay. So don't turn that oven on and then go do the inspection. You come back and you've cooked whatever's, the kitchen smells and maybe there was something in the oven that shouldn't have been there, and now you've got a big problem on your hand. What you want to
And
do before you go ahead, Stan.
also with new construction and or flips, if so I open that oven door, and if the foam is still in there and the plastic and all that stuff, I am not turning those appliances
Nope.
on.
I don't
I'm
run
going to
any
tell them
appliance that's installed like that. Yeah.
because they didn't turn it on, right? If the packaging is still in there, they
Yep.
never turn those appliances on. They have to, and I put that right in the report. Most people understand that we're not
Yep.
going to be the first person to turn that on. I'm not taking the stuff out and turning it on. Somebody else has to. That's just the way I handle it.
Kitchen inspection, cabinets, countertops, and flooring. Cabinet inspection. Check cabinets for sign of water damage, loose hinges, improper installation, open and close doors, and ensure smooth operation. Look for any signs of pest infestation or wood rot. Countertop examination. Inspect countertops for cracks, chips, or loose seams. Check the backsplash for proper sealing and signs of water damage. Ensure countertops are level and secured attached to the cabinets. Flooring assessment. Examine floor for wear, damage, or improper installation. Look for any signs of water damage, particularly around appliances and the sink area. Check for loose tiles, lifting vinyl, or squeaking floorboards. Safety check. Identify any potential hazards such as sharp edges, loose fixtures, or uneven surfaces that could pose a safety risk. Ensure proper support for heavy countertop appliances. Back to the dishwasher for a second, because we're talking about countertops. Make sure your dishwasher is connected to either the side, to the cabinets or to the countertops. Some of them are, I'll go in to do an inspection, I'll pull the door and I'll practically pull the whole dishwasher out because it's not connected. So you want to check for that connection. And what your client's always going to ask you, can I paint these cabinets? That's a yes. Types of kitchen cabinets. Common types, several standard configuration. We have stock cabinets offer pre-manufactured standard sizes. You have semi-custom options to provide more flexibility. Custom cabinets are built to the exact specifications for that kitchen. The main types include base cabinets for floor standing storage, wall cabinets mounted above countertops, and tall cabinets extending from floor to ceiling. Construction materials. Cabinet construction uses various materials, each with distinctive advantages. Solid wood offers durability, traditional appeal, while MDF provides moisture resistance. Plywood ensures strong, stable construction, and particle board offers budget-friendly alternative. Laminate serves to protect surface coating for enhanced durability. Inspection process. A thorough cabinet inspection involves checking door alignment, hardware function, inspecting for water damage near sinks and appliances, testing the draw slides and closing mechanisms. Inspector must look for signs of pest infestation, properly mounted supports, and just the overall cabinet box integrity. The types of different countertops. We have granite, natural stone with unique patterns. It's extremely durable, heat resistance, and long lastings. Requires periodic sealing to prevent staining. Quartz, engineered stone that is porous and maintenance free, extremely durable with consistent patterns, resistance to scratches and stains. We've got marble. It's a classic natural stone with elegant veining, softer than granite and prone to etching, requires regular maintenance and sealing. Butcher block, it's a warm, natural wood surface, can be sanded, refinished, requires regular oiling and careful maintenance against moisture. Stainless steel, professional grade material that's heat resistant and hygienic, can show scratches and fingerprints, but it's extremely durable. And we have our laminate countertops, budget friendly option with many choices, less durable than stone, easy to clean, can be damaged by heat and sharp objects. My only comment on this is sometimes we're not having the best of days. You can get to an inspection, you can look at something quickly, and the new laminates can be absolutely undistinguishable if you don't touch them from granite. They're really good today. And you write in your report, the granite countertops look great and they're secured to the cabinet base. The people move in, they're like, hey, we have laminate and we wouldn't have bought the house unless we thought it was granite. So you're putting in granite countertops. If you're be sure of what the material is, and if you're unsure what the material is, don't put the material in. Just say the countertops and you'll protect yourself that
Yeah,
way.
I don't identify material
There you go.
for that purpose.
Types of kitchen flooring. We have ceramic and porcelain tile, which is very durable, water resistant. You want to check for cracked or loose tiles, inspect grout lines, properly verify slope away from cabinets, look for signs of moisture beneath the tiles. I don't know how you do it. Hardwood, traditional choice offering warmth and character. Examine for water damage near sinks and appliances. Check for cupping, buckling, or separated boards. Verify finish condition and wear patterns. Test the floor stability and subfloor condition. We have a vinyl or LVP, cost effective, waterproof flooring solution. Look for seam separation or lifting. Check for wear, layer damage. Inspect for proper installation around fixtures. Verify transitions to other flooring types. Make sure that's done properly. Natural stone. Um, if you can afford it, it's a luxurious option, including marble, granite, or slate. Again, you want to check for the condition, look for chips, cracks, surface damage, and then verify proper support structure. Test for loose or hollow sounding tiles. Um, I usually just will tap on a tile if I feel that there's an issue and see if it's hollow underneath. But mainly, I'm just looking for grout, cracked tiles, that kind of issue during an inspection. Kitchen islands. Um, so structural integrity. You want to assess the weight bearing capacity by verifying a minimum 2x4 support beams at 16-inch intervals. Confirm the island is anchored to subfloor with appropriate lag bolts at each corner. Examine diagonal cross bracing for proper installation and stability. And perform stability tests typically under conditions minimum 200 pounds. Electrical components. Verify 20 amp GFCI protection on all receptacles within 6 feet of water surface. Confirm outlets are spaced maximum 48 inches apart. Test LED under cabinet lighting. Inspect junction boxes for proper wire connections and heat displacement. Plumbing features. We talked about this, about verifying the P-trap installation. Inspect PEX or copper support lines for secure mounting and anti-stress loops. Test the drain slope. Use a moisture meter to detect any hidden leaks around supply connections. surface conditions. Check for a minimum of 1.5 inch overhang on all sides of the countertop. Inspect silicone seams for proper gap filling and curing. Verifying stone surfaces are sealed with appropriate penetrating sealer. Document any impact damage or heat rings exceeding 1 inch, 1/16 inch depth. So this is all nice, but basically on an island, I want to determine whether it's secured to the floor or whether it's movable. I want to check to see if there's an outlet on the island. That's something that needs to be there, because if you're going to plug in a computer or have a crock pot, you don't want to use an extension cord. Kitchen appliances. The refrigerator temperature settings between 35 and 38 degrees. We want to check the door seals and drainage systems. I'm not going to be looking at the condenser coil condition, proper ventilation clearance, and in Connecticut, we don't test for ice maker conditions. We're not required to do that. Stove and range, 30-inch clearance required, burner and oven functionality, gas connection, anti-tip bracket installation, and electrical connections. Dishwasher, you want to inspect the water supply and drain lines, high loop installation, which we'll get to in a minute, door springs and seals, GFI protection. The microwave, this says 13 inches minimum above clean stop. It's not, it's a minimum of 18 inches. And even more. I've seen 24 to 30 inches in some cases, depending upon the use. So run your microwave. You're not supposed to run a microwave when it's empty, but you don't run it long. Test the ventilation system and the electrical connections. Garbage disposal. You want to check the mounting, splash guard conditions, if it's on a dedicated circuit, and the drain connection. On a dishwasher, back to the high loop. That is where the dishwasher drainage line loops up so that dirty water can't get back into the dishwasher. So you want to check for that. Garbage disposal wiring. Under the kitchen sink, the wiring for a garbage disposal typically falls into one of two setups, depending upon how the disposal is powered. Cord and plug-in. This is the most common on newer models. The disposal is connected with a dedicated outlet. The outlet is controlled by a wall switch near the sink. Ground fault circuit interrupter. The cord must be a factory installed UL listed cord, flexible cable with a molded plug, properly clamped to the disposal's junction box to prevent against strain. Other wiring considerations: no splicing. Romex cable is not allowed to be exposed under a kitchen sink unless it's protected in a conduit. The outlet or switch should be accessible, not obstructed by plumbing or garbage disposal components. And then in some cases, air switch controls installed in the countertop may replace the wall switch. Hardwire connections. The disposal is directly hardwired to the electrical box. This is less common today. And a dedicated circuits used. The wiring enters the disposal through a flexible conduit or armored BX cable. It must have a disconnect means, such as a wall switch or a junction box, and a strain relief connector at the disposal. Ground wire connection to disposal's ground screw. So inspector tips: ensure proper bonding and grounding to metal boxes and conduits. Check for GFI protection. Verify the wiring is secured and mounted and not subject to moisture or damage, and confirm the circuit amperage is appropriate for the disposal's rating. That's a lot. So basically what I do is I just turn the garbage disposal on and I check the wiring underneath. That's check for any leaking. Ventilation. We got to move along because we're halfway through. Range hood inspections. Examine the range hood for proper installation and clearance above the cooktop. Test all fan speeds, light functions. Check for excessive grease buildup or damage to filters. Ensure the hood is vented to the exterior or not recirculating air into the kitchen. That, again, if you have one that recirculates, that's what it's going to be. Exhaust duct evaluation. If possible, inspect the exhaust duct for proper sizing, minimal bends, and secure connections. Look for any signs of leaks, condensation, or backdrafting. Verify that the duct terminates outside the home and not in the attic or crawl space. Airflow testing. We can use a tissue or smoke tester to check for proper airflow in the hood intake. Measure the capture area to ensure it extends over all the burners. Okay. So for more accurate results, consider using an airflow meter to measure the exhaust rate in cubic feet per minute. I can tell you most people just turn on, see if it works, and explain where it's going. Um, Common defects, ventilation and safety issues. Inadequate ventilation, poor or inadequate ventilation can lead to moisture buildup, odors, and potential mold growth. Check that range hoods are properly sized and vented to the exterior. Again, we talked about that. Missing anti-tip devices, we talked about that. Check your oven. You can pull on it a little bit to see if that anti-tip is there. Stan and I talked about this earlier today. Basically, what I do is I'm not testing for that a lot of times because I can't get behind the range. Um, but I guess what we're gonna do is put in our report that we have that you what I do is I tell my clients in my report, you want to make sure that your stove has an anti-tip device. If it doesn't, you need to follow the manufacturer specifications. Fire hazards. Look for potential fire hazards such as flammable materials, excuse me, near cooktops, overloaded circuits, or damaged appliance cords. Ensure that they're functional fire extinguisher present and easily acceptable in the kitchen. So we want a fire extinguisher there. Ventilation height, we go this under the cabinet hood, 24 to 30 inches. Again, minimum of 18 inches. A wall mounted chimney is 26 to 30 inches. An island hood is 30 to 36 inches. And a commercial hot style hood, 30 to 40 inches. You'll come in and you'll see a lot of these microwaves. You put a new microwave in and I can't fit my pot under, underneath it because the microwave sits so low. So I usually go by the 18 inches. If it's 18 inches, it should be fine. Safety hazard, we talked about this. Tripping hazard, fire safety check, and accessibility evaluations. So you want to make sure you're able to get to everything, check for tripping hazards, and you want a fire extinguisher close by. Limitations, we're not going to be able to see concealed components under inside walls, under flooring, non-operational appliances. If something's not working, you've got to tell you in the report, I didn't test it because it's not working. And built-in appliance testing, you want to limit it to verification only. Okay, you're not going to open it up. You're not going to get into the electronics or anything like that. Storage and access, cabinets and storage filled with personal items may prevent thorough inspection. So you want to note this in the report. I couldn't see underneath the sink because it was packed. And time constraints. We don't want to be at a home inspection for 9 hours. So, standard inspection time frame may not allow for extensive appliance testing or detailed evaluation of all components and systems. All right. So now we're going to move on to the bathrooms. Again, sink inspection. We want to check for leaks, proper drainage, secure mounting. We want to test the water pressure and the temperature. We want to inspect underneath the sink for signs of leaks, corrosion, or improper connections. We want to verify the P-trap. We want to test the drain stopper, examine the supply lines, make sure they're shutoffs, check the faucet aerator for mineral buildup. We want to inspect the sink for any kind of cracks. And again, we talked about the shutoffs underneath the sink. Toilet examination, verify proper flushing and refilling operation. Check for leaks around the base and the tank. Ensure the toilet is securely fastened to the floor with the proper wax seal ring. We're not going to check for the wax seal ring, but I always give the toilet a good tug to make sure it's tight on the floor. So measure the tank fill and flush times. I really don't do that. I flush it. Test the flush valves and flapper, check the bowl rim for proper flow distribution, and then inspect the lines that supply the toilet. Tub and shower assessment. Again, we're going to inspect for leaks, proper drainage, and secure fixtures. Check caulking around grout condition, test the water pressure, anti-scald, temperature control function. We want to evaluate the shower diverter. And honestly, that's like 35-40% of the time they never work. Check for proper shower pan or tub drains. Inspect the tile surround for damage. Test the shower head flow. Verify caulking in all joints. So when I go into a bathroom, I'm letting the water run the entire time I'm in the bathroom. I'm flushing the toilet. I want to make sure the showers are running, the sinks are running, checking for leaking, and I'm testing the GFI outlet, checking to see what kind of ventilation there is. So we'll get that. So we're going to go in a little bit on toilets and their history. This is a little just information so that you're fully informed. Ancient civilizations, first seated toilets appeared um, when the ancient Romans developed sophisticated public latrines with running water. Then we went to chamber pots in the 1800s and the flush toilet revolution in the later 1800s, and then modern toilets with gravity flush systems, pressure assistant technology, dual flush options, and our toilets today conserve water, and new designs are always happening. They have toilets today that can test your urine and see if you're healthy or not. It's kind of crazy. Again, moving on to the modern toilet, John Harrington by 1596, the first modern flush toilet was invented. Alexander Cumming, the siphon-based toilet design, closer to what we use today in 1775. And Thomas Crapper, 1836 to 1910, popularized the modern toilet by improving the flush mechanism, manufacturing high quality fixtures, leading to the widespread adoption of flush toilets. I don't think we're going to have any clients ask us about who invented the toilet. Bathroom inspection, plumbing systems. We want to test the water pressure. Um, just don't necessarily use a water pressure gauge to measure water fixtures, but I check to see what it looks like. I like to have my client there when I do that, because if it's suspect, I'll look at the client. I'm like, is this pressure good for you? Are you happy with it? And a lot of times they'll say, yeah, 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 it's fine. I'll still put in the report that it's lower than what I normally see, but it's always good to have the client there if you feel that there's an issue with the pressure. Drainage evaluation, test all the drains for proper flow and signs of backup, listening for gurgling sounds that we talked about. I'm definitely not pulling out a stopwatch to see how quickly the water drains, but this is in our webinar tonight. Caulking and sealant inspections. Examine all the caulking and sealants around the tubs, fixtures, and showers. Look for signs of mold, mildew, discoloration. Check for gaps that could allow water penetration in the walls and floors. Properly applied caulk is crucial for preventing water damage and maintaining sanitary bathrooms. So drainage is a kind of weird thing. I had inspection today, as a matter of fact, and the main floor tub would not drain at all. The second floor bathroom sink would not drain at all. And basically, and everything else drained fine in the house. And what I discovered was the stopper on the tub was defective. It was just not moving. And they had one of those flex drains underneath the sink, which I think was holding up and was kind of filled with debris and stuff like that. So not too much of a problem, easily fixed. Um, okay. Bathroom inspection, ventilation and moisture control. We want to operate our exhaust fan. We want to test the bathroom exhaust fan for proper function and adequate airflow. Ventilation capacity. Not necessarily going to check the CFM ratings to assure proper floor, but we all know when that older fan is not cutting it. As a rule of thumb, you need 1 CFM per square foot of a bathroom area with a minimum of 50 CFMs for small bathrooms. Duct inspection, verify the exhaust fan is vented to the exterior, not into the attic or wall cavity. Check for proper duct installation into unconditioned spaces to prevent condensation. Moisture detection, use a moisture meter to check for hidden moisture in walls, floors, and around fixtures. Look for signs of water stains, peeling paint, warp materials that might indicate ongoing moisture issues. So again, these are common sense things. We want to test the fan, and then make sure that fan is not going into the attic like they normally do. Your second code is KB65201. That's KB65201. Electrical in bathrooms. We want to make sure that we have GFI protection. We want to check the lighting. Again, we're checking the exhaust fan. and for any electrical hazards. Look for any signs of water damage near electrical components. Check for proper clearance between the water source and electrical outlets or fixtures. Identify any DIY work. When you're standing in a tub, it is my understanding, or a shower, you are not supposed to be able to reach any outlet. That is not a good thing. Walls, flooring, and fixtures. Again, this is kind of easy stuff. We want to check the wall condition for damage, mold growth, tile work. Floor inspection, check for flooring damage, loose tiles, worn grout, verify proper drainage slope and examine vinyl seams. Um, Fixture evaluation, assess security of mounting fixtures, shower door operations, and ceiling effectiveness. Examine bathroom tub shower surrounds for cracks, deterioration that could lead to water damage. Um, yes, so that's a good question, Giuseppe. So we have a question here. It's very common to test the GFCI in older bathrooms and it is not grounded. The button on the tester will not trip, but the test button does. Do you fault it? So we come into that more and more. What I'll do, what he's talking about is you plug your tester in, you hit the button and it doesn't work, but you hit the button on the GFI network. So you're going into an older home that might have knob and tube wiring or ungrounded wiring. The way to fix that can be to put a GFCI breaker in there, and that is protecting the client, and that is acceptable. What I tell, how I don't fault it. What I do is I tell the client verbally, this is why this is happening, and I'll assess the client. You know, if you've been doing this long enough, you know what you need to put in report for what clients. If I have a first time owner buyer, I'm going to put a comment in that says, here's the problem. It's a non-grounded outlet. It has been corrected by putting a GFCI outlet in there. But it is not going to trip in the proper manner. And there may be an electrician or a handyman that does not understand that. There's nothing wrong. I'm confident that you're going to be safe. But if I have a more experienced client who looks at me and goes, yeah, I get it, I'm just going to put in there that it's GFI protected, so that's how I'll handle it. Bathroom inspection, safety and accessibility. Grab bars, check for the presence of them, proper installation, ensure they're securely anchored. Accessibility fixtures, evaluate the bathroom for accessibility fixtures, raised toilets, walk-in showers, sufficient space for wheelchair maneuverability. Non-slip surfaces, you want to assess the shower floor, and an emergency access. Ensure that bathroom locks can be easily opened from the outside in case of emergencies. Check for potential obstacles that can impede in quick access. So, these are things that, especially for older people, this is what we want. If I go into a retirement community, I'm definitely looking for grab bars and that kind of thing. Common, well, so we going back to kitchens for a minute. Again, this shouldn't be in here, but we're going to check for leaking faucets, slow drains, and pipe corrosion. Back to bathrooms. Um, Bathroom defects, moisture related issues. So we're going to be looking for water damage on the ceilings and the walls. We're going to look for mold growth, inadequate ventilation, and caulk. We've talked about all this. If you don't have a fan in your bathroom and they're not going to open up the window, you're going to get mold. You're going to get high moisture, and that lack of ventilation is going to be a buildup of a lot of problems that we don't want. Mold growth in bathrooms, shower corners, grout lines, ceiling corners, especially above the shower, underneath the sink and cabinets, around the toilet base, windowsills and frames. Um, to look for that, we know what to look for. That's going to be black, green, or brown spotting on surfaces, musty, earthy odors, bubbling or peeling paint, water stains and discoloration, and excessive humidity levels. You're going to use your moisture meter. You're going to check the ventilation's effectiveness. Again, we're looking for plumbing leaks, and you're going to document all this with photos. And then you're going to give recommendations. All recommendations should be from a licensed contractor, a licensed plumber going forward. Okay, let's see what we got. We talked about leaky fixtures. We're going to look for shower heads, toilet connections, toilet problems, looking for leaks around the base, check for proper flushing. We've talked about this. Pipe issues, inspecting visible pipes for signs of corrosion leaks, improper installation. Um, you also want to spend special attention to connections in areas prone to freezing and colder climates. You have um, a sink near a window on the outside wall. We want to make sure there's good ventilation underneath there and heat so that we don't get um, freeze. Drain problems. Test all drains for proper flow. Slow drains may indicate clogged or venting issues. All right. Flexible piping underneath sinks. So basically, I've added this in because I get a lot of questions from customers about it. So I put this in here, and what I found out was, when is it allowed? Suppl- Flexible water supply lines. They're permitted and common, typically made of braided stainless steel and real reinforced polymer. They must be rated for potable water and should not be kinked or excessively twisted. Must be properly secured at both ends. Flexible drain tailpieces connection, limited use. Plastic corrugated drain tubing, accordion style, is technically allowed in some jurisdictions, but is not generally recommended for permanent installations. It may be used for temporary repair, short connections, and you want to still maintain those proper drainage and slopes. Conditionally allowed, corrugated accordion style trap assemblies often found in DIY homeowner repairs. These are not recommended by most plumbers. Problems associated with them are building backup of debris on the ridges, increased risk of clogs and slow drains, leaks at joints. Um, Not allowed. Flexible gas piping, such as CSST or appliance connectors, should not be used underneath the sink unless specifically rated and installed per code. Any flexible water lines with visible damage, leaks, or corrosion should be replaced immediately. Unlisted or homemade drain assemblies are strictly prohibited. Common defects, electrical safety concerns. Lack of GFI protection. We want to ensure that all the outlets are GFI. We need proper lighting, inadequate ventilation, and safety hazards. We talked about all this. One thing that we want to extend on the lighting is the light over the shower. And I get that question a lot. And I used to call it out all the time, is that, hey, you have a light over the shower, it needs to be connected onto the GFI outlet. And then, I got a lot of pushback. I had an electrician call me one time and said, you don't know what you're talking about, blah, blah, blah. And I was like, listen, I don't get into it. It's there. No one's removing that light. And what I usually tell people to lighten up the mood of the home inspection, I was like, as long as you're not changing your light bulb while you're showering, you're going to be in good condition. And usually it gets a laugh. But I tell people, you do have electricity where you're showering, and you need to just be aware of that. But it should be connected. That light should be connected to the GFI so it turns off if there's a problem. Electrical panels in bathrooms, they're not allowed. Okay. Not located in bathrooms. Devices shall not be located in bathrooms. This applies to main service panels, sub panels, any panel containing circuit breaker or fuses. Why is it prohibited? Bathrooms are moist environments, which increases the risk of corrosion, electrical shock, and unsafe working conditions for servicing the panel. There are also clearance and workspace requirements that are hard to meet in a bathroom. Again, it needs to be put into an alternative location, like alternative adjacent hallway or closet, basement, utility room. Um, if you find this in the bathroom, call it out as a safety violation and recommend evaluation by a licensed electrician. Again, we talked about outlets and bathrooms. They have to be GFI protected, blah, 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 tamper resistant. And one of the things we added is the prohibited locations. Outlets are not prohibited inside the tub or shower enclosure, face up on horizontal surfaces, or installed lower than floor level. Limitation of bathroom inspections. It's a visual inspection only, non-destructive testing. We want just to normal operating controls. We want to be kind of aware of our inaccessible areas and our time constraints. We do not want to be in a bathroom for 35 minutes. That is not a good thing for anybody. Just test your systems and explain to your client and move along. You will have clients just want to stay in a bathroom for some reason. I've had a couple of them, and they're like, "Can I do this? Can I do this? Can I do this?" And just say, I always tell somebody, with effort or a lot of money, you can do anything, and move along. Um, we talk a little bit about advanced inspection techniques. We can use our moisture meters. Many inspectors are using thermal imaging. And then we can use our hydrometer for measuring relative humidity. I'm not a big fan of, I'll use the moisture meter. The thermal imaging, you know, I don't use it, but it does not mean that you cannot. I would just get very well trained on it, because you do not want to be pointing at stuff and not knowing what you're talking about. Effective writing and reports. You need to be clear and concise. Use simple, straightforward language to describe issues. Avoid any technical jargon. Be specific about the location and nature of the defect. Um, Provide context. Explain why the issue is important and what potential consequences it may have if left unaddressed. This helps clients prioritize repairs and understand significance of your findings. Include visual documentation. Whenever possible, include clear, well-lit photographs of defects or areas of concern. This provides visual evidence and helps clients understand the issues more. Offer recommendation. Provide actionable recommendations for addressing each issue. This might include suggesting further evaluation by a specialist or outlining potential repair options. So be clear and concise. What I do about the location, you're walking through a house and you have several ungrounded outlets. Um, I'm not going to be sitting there telling you where every single one is. What I've done now is I just go to a picture. I'll take a picture and I'll label it right at the inspection of where it is. And then in my report, I'll say, there are many ungrounded outlets. See pictures for locations. That saves me time and it lets them know where it is. Writing effective inspection reports, structure and organization. I'm not a big fan of the summary. I was taught that if you put a summary in, you can have issues with that, because if you miss something in the summary that's in the report, that can be problematic. You want detailed findings. Organize your report by room or system. We pretty much all do that. And then supporting documentation include photographs, diagrams, and all that. Language and tone. You want to use objective language. Stick to factual observations rather than subjective opinions. Describe what you see, not what you might think have caused it. Avoid alarmist language. You want to be consistent and you maintain your professionalism. This sounds easy, but you're dragging around 10 or 15 people around an inspection. You got two sets of parents. My sister came in from Oklahoma to look at the house. I've got 19 people here, and dad's saying none of this is meeting code. And why aren't you telling them that they have to replace this? You just want to be objective. You want to be sort of consistent throughout the report, throughout your inspection, and just put in the report what you see, and you will be okay. We hit it. I want to thank everybody for coming here tonight. I just want to know if there's any questions or anything that we want to talk about. Stan, do you have anything that you want to cover?
No, I think that was pretty, covered everything, I think. We spent more time on kitchens and bathrooms than I do when I inspect a house.
Yeah. It's absolutely that.
It's funny because when you've been doing it for as long as I have, it's a process that you develop and you just like fly through it. You know what I mean? You know what you're looking for and you get it all done. And I will also ask people if they have any questions when I get done with one of those rooms as well.
Right. What I usually do is when I get to an inspection, I'll tell the client what I'm going to do in order. I'm going to do the outside if I've not already done it. I'm going to do the garage, then I'm going to start in the kitchen, then I'm going to move through the house, then I'm going to go into the basement. But when we were putting together this webinar, Stan had said to me, are we going to be able to get an hour, like he just said, out of kitchens and bathrooms? And I was like, you wouldn't believe the information out there. Some of it's going to be kind of dry and repetitive, but an inspection I did today, the gentleman said, this was a great inspection. It must be difficult to know all these different systems. And I was like, it's really not difficult. It's if you're prepared, if you've done it numerous times, if you're organized, if you have a pattern that you do. And as you can see, I move through the house the same way on every single house. When I go into a bathroom, I start with the sink, I flush the toilet, I run the tub, I check the GFI, I check the lighting, I check the floor. I start from the ceiling and I work down to the walls and flooring. And I do that on every single inspection. Now, it's boring, but you're not going to miss anything, because if you do the same thing again and again and again, and you get into that routine, it's just it just makes me feel comfortable the way I do it. What we want to get away from is we're in the kitchen and your client wants to talk about the attic, and you're going to go run and see the attic. That's not a good thing either. You've got to control the inspection. And again, kitchens and bathrooms have a lot of similar things that we're going to be looking for through them. We've talked about, wear and tear, GFIs, drainage, and all that. But they're very. Stan, let me ask you one question, and then we'll go. When you write your reports, do you write each bathroom separately? Do you go
No.
bathroom one? No. So
Nope.
you combine them. Okay.
Yep.
Yeah, that's what I've been doing.
I'm going to tell, so the new guys out there, the newer guys, when I first started 37 years ago, I probably started out just like all the new guys. You got some advice, you bought all the tools, but really, really early on, I started realizing that a lot of the stuff that I was doing was not. Like, I used to take hot water temperature immediately when the faucet's open, and then 10 or 15 minutes later to see what the drop was. I started realizing that stuff like that was irrelevant to these people. It's either hot or it's not. Um,
Right.
Either the pressure's good or it's not. They don't need to know that it's 32 pounds or 42 pounds. I stopped doing all that stuff. It makes the report much clearer. To me, today we're getting into too many things that muddy the water, and people may not be able to pick out the things that are really, really important.
Exactly.
But as you said, maintain a procedure and control the inspection. If there's
Yep.
people there that are distracting you, you got to tell them to stop,
Yep.
or move on by yourself and come back to them and show them your findings. But follow your procedure and control the inspection.
Yep.
And you can only
Cool.
get so many people in a bathroom, right? Unless it's a massive bathroom. So
It's
tell them you might
shocking.
have to use it and close the door on them.
So we have our logos for participation in this available on our website. That page on our website is downloadable logos, I think, and it's password protected, and the password is Cornerstone. That'll be available tomorrow morning. I'm going to get certificates out tonight, so you should get them in about 15-20 minutes. And then next in 2 weeks, we have a presentation on log homes. And again, if you know any other inspectors, tell them to join us. We always need new members. And if you have any topics you would like us to talk about, just email us and we'll get them up and running. Thank you very much, everybody.
Thanks, guys. Have a good evening. Take care.